Hello?
Hello.
Hello?
Hello? All right.
Hello.
Okay, so now this is integration by parts, and it's no. Okay, so if you guys remember when we were doing regular integration and we had to U sub, what type of problems did I U sub? So if I was taking the derivative of that same function, what would I try to do that made it that I wanted to do a U sub? Say it.
Chain rule.
Chain rule. Very good. Chain rule would make it so that I'd be like, hey, if I'm looking at derivative, this little nasty piece in here, that's going to be the chain part of it, right? That's the part I want to U sub to try and make it. So whenever looking at that, you're like, oh, hey, I could U sub this to try and make it easier to do, or whatever identities I have that might eliminate that possibility. Integration by parts is product instead. So if I'm looking at something, I'm like, hey, if I take the derivative of that, that would be a product, wouldn't I? Oh yeah, okay. But now we're doing integration this time though. So it's integration of something. So now when we do this, it's going to be here. Let u equal f of x. So u is the function. Hello? 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 Hello, McFly? Hello?
This is all gonna come.
Hello?
Yeah.
What? What was that?
Michael was like,
He looks scary.
you can see it.
He's walking around.
I should be playing elevator music.
Okay, f of x is my u and v is the g of x. Okay? F of x is the u and v is g of x. We can use their differentials, which du, so the derivative of u, okay, is f prime dx, and derivative of v is g prime dx. To obtain the formula we usually use, so of my thing right here, whatever the function is going to be, I'm going to break it up into a u and a v. Okay? So I have uv and minus integration of v du, or u du. V du. Okay. Integral of the product of u dv is equal to u times v minus the integral of the product of v du. Okay. Now, goal of integration by parts is to choose u in dv. So that means there's a derivative, right? So that this is the integration of v is easier to integrate than the integration of u.
English?
Here's English. Which part of that's easier to integrate? This one should be easy. Okay, so I'm trying not to be too bad on this. All right, so let's label our pieces. Okay, so I'm going to say that u is equal to x. Okay, u is equal to x. And then v is equal to her right there. E to the x. And that would be my dx. It's dv, sorry. dv is equal to e to the x dx. Because I got to take care of all parts of that. So let's go ahead and get my du. So to get my du, I would do what? Yeah, so I get du is equal to dx, right? Yes? Okay, so we're taking the integration of the other part, right? Because I have a dv, because I have an e to the x dx that I'm taking care of. E to the x dx is what I'm taking care of here. So I took care of my u was my x, and my dv, which I'm trying to get to, was the e to the x dx. So what is the integration of e to the x? E to the x. Okay, so now this is going to be the integration. So from this, it's going to be v is equal to e to the x plus c, right?
Yes.
So, my formula. Let's go back to the formula. It was uv, right? It's supposed to be uv minus integration of, what was it? V du. All right, so you ready? So for this piece right here, what is my u? X. So it's going to be x times, for in this case right here, I'm going to leave off that c, because when I'm done, there's going to be some constant, okay? There's going to be some constant that I'm going to add to this. So times, my v is e to the x, right? Minus the integration. Okay, integration is going to be e to the x, and then it's going to, what am I changing? Okay, I changed that one right there, right? So now that one's going to be my dx. So my du is my dx. Because I took this, I took the derivative of it. When I actually deal with like bigger numbers, this is actually going to make a lot more sense on this part right here. So right now, since I'm only dealing with one, it's really not going to change much. So there we go. Let's go ahead and now put this together. So for this right here, go ahead and do it. So multiply these together, I get x e to the x minus e to the x plus c. So we found the integration of this whole nasty thing of a product, right? Remember? The product comes out to be this. So when I take the integration, this is what I get. Make sense or no? Complete and total nonsense, right? So, everyone okay? All right, so now that we have that, let's take a look at this thing. Oh, second part. What's my x?
Well, your u is x.
My u is x. My u is x. And my v is, or my, I'm sorry, my dv. So du is equal to dx. And for this case right here, I'm going to get v is
Negative plus, yeah, negative plus.
right? And then plus the c, right? Okay, so We have those values right there, so let's go ahead and start plugging stuff in. So it's going to be UV, so my U is X, right? So it's going to be X times negative cosine of X minus integration of what goes next? It was V, right?
Yeah.
It is cosine, right? Or sine? Which is it? Negative cosine X. And right? So I'm plugging stuff in, and so now I could actually put this together. So can I take out that negative? I don't like having a negative inside there, especially when I'm minusing. So I can take that negative and put it where? In front of my integral, right? So if that goes in front of my integral, so let's take a look. So from here, it's going to be minus x cosine of x plus integration of cosine of x dx. So negative x cosine of x, that's going to be plus, what is the integration of cosine? Sine. Are we okay? Not too bad, right?
Do we use the DV?
We will. Right now we're just using x right now, and so it's really not going to be useful until later. And so this one right here, the dv, it's actually just part of this. All of this stuff is important, and we're identifying parts for this. Okay, so now the thing is, for when I took the derivative of this, that means I'm taking the derivative, and I also have the integration is what I'm going for later on, right? So when I'm doing this, I take the derivative and I'm plugging it in because I want the integration later on. So for this one right here, I could do the integration of just that one piece, okay, without actually complicating it anymore. So I took this to get that over there. So all this right here to uncomplicate this. And right now with the just u and the x, that piece is meh right now. But this right here is part of the things that we're identifying. So the dv, we're eventually, because remember when we did u sub, we had to be kind of tricky with some of the values that we used. And then it had to substitute something else out. And we needed to take that piece out by itself, right? So we're eventually going to have to do something like that. Does that make sense?
Yeah. So
Okay.
It's gonna end up making
So yeah, it's, right here, the du is equal to dx. Okay, so it's really eventually. But as of what we're doing in this moment, we're not getting that into it. Okay? All right. So, all right, let's take a look at the next one then. All right, so we're going to derive this formula. Why does that look odd? I'm missing something, right? Is that a plus c?
It's supposed to be
Minus x and plus c. There we go. It's weird. Minus x and plus c. All right. So, to derive this formula using integration by parts, I have to pick values that I know. But don't we already we kind of treat this integration already as like an identity. So I put it on your flashcards and I'm like, hey, what's the integration of ln x? And you would say all that, right? So yeah, so hopefully if you are using your flashcards, you would be like, oh yeah, I got this. But if not, you're like, okay. So we're gonna actually try and figure out how to do this. So I need to identify certain things. So if I say that ln x is my u value, could I do that? So if I do that instead of my v, I can go through and actually make this a little bit easier because I know what the derivative of ln x is, right? Say yes. Okay. Is there something there? So I could say that u is equal to ln x. And then what would I do for my v then? My dv. So my dv would be what? Equals 1. And that would be my dx, right? Yes? So it's going to be my 1 dx. So there is one there. If there is just the dx, there's at least one there, right? So my du is equal to what? When I take the derivative of u, I get du. When I take the derivative of ln x, I get, so it's what? 1 over x dx. Yes? Okay, so now what about for this one right here, what about the other part? Okay, so what is my v going to be? It would be what? X, right? So for this one right here, this is going to be x. And then the plus c from there, right? All right, so I'm looking at some blank faces. Did I confuse the crap out of everyone and I lost everyone at a certain point? Where did I lose you and what's going on? You can't say it's Monday because it's Tuesday. This is something brand new. Is everyone on board with this? Anyone not? Anyone have serious questions because it's only going to go from here? Yeah, plus c, but like I said, it's an arbitrary c that's going to be added on anyway when I actually get to my integration of the parts part. Okay? Does anyone have any questions over any of this so far? Okay, so let's write this out. So it's going to be u, so that's going to be, so it's going to be uv is going to be x times ln x minus integration of say x. But what is my dx going to be now? Because this started off as a u, right? But what is my dx?
1 over x. Yeah.
There we go. So that's where I get that piece right there. Did I lose anyone with what I did? Because the 1 over x came from right here. That's my 1 over x dx. Now, what's going to happen to those x's? It's going to cancel out, right? It's going to cancel out. So let's do the math now. So it's going to be x ln x minus, so that's just going to be 1, isn't it?
Yeah.
So the integration of 1 just gives me x
Plus C.
plus c.
Wow. I actually like it.
Wow, we.
Mr. Tacho,
Yeah.
what's the integral of sin x?
What's the integration of sine?
Yeah.
Okay, so if I draw my circle, remember we had this kind of like as a from derivative, so it's sine here, right? And it's cosine, and it's negative sine, and it's negative cosine, right? So a derivative goes clockwise, right?
It goes clockwise.
Yeah, a derivative, so dx goes clockwise, goes this way, right? Because the derivative of sine is cosine, right? Derivative of cosine is negative sine. Derivative of negative sine is negative cosine. And derivative of negative cosine is positive sine. So that's the derivative, right? But if we're taking the antiderivative, I would go counterclockwise, right? So let's take a look. So going counterclockwise, bam. Nope, wrong one. So right here, I would have sine, cosine, and negative cosine, right? So this time, if it's integration, so I'm going to put the integration symbol like that, it's now going to go this way. So integration of sine becomes negative cosine. Integration negative cosine is negative sine. Integration of negative sine is positive cosine, and it just keeps going. So, make sense?
Yeah.
Okay, good. All right, so integration by parts on this one right here. So I'm going to save this one till tomorrow. That's 4 and 5. Yeah, I'm saving these for tomorrow. Okay, I want you guys actually working on this and trying this, please, 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 please. Please sit and work on it. If you take out your phone,